Hello, folks. It's George Leoniak, and welcome to New Geometry. I am super excited today to be sharing a video about the Krystal Spiral and lots of new discoveries about the spiral and the grid and lots with the geometry. Today, I'm also thrilled to be in this video, finally being able to share this incredible form that I made, which is made out of these imploding spirals into the center. So sit back and enjoy. We're going to get into this one and talk about the Russian pyramid in comparison to a new pyramid structure that I have just developed and worked with as well. So there's going to be a lot of interconnected themes from many of the other videos, and I'm going to start off with a little bit of a bang here. So let's get started, and I'll do this slide share here. All right, wait, what? The Krystal Spiral is in the seed of life? Yes, this Krystal Spiral, this shape over here on the left, which many folks are familiar with, being in a square view pattern with squares within squares. You're going to see a lot of those images in just a little bit, but this is made one of the main units that's pulled out from that. You see we can kind of work our way around by connecting the edges of these squares as we go further and further in. And it can be drawn in the seed of life just as, probably even more easier than drawing all the squares, because the seed of life and the, these could be stars. If we do a full triangle here, we can make the hexagram stars. You can cross two of those edges there, and you'll be picking up the points as you go around right within the seed of life pattern. So there's nothing wrong with the hexagon pattern to be able to draw this template, and you can see that it fits right over top of it, just like that. So that was a kind of new discovery of mine that was quite cool to see, that, you know, this pattern that is so associated with the square view and has a anti-hexagon flower of life opinion of, you know, disliking that pattern strongly, that the same beloved pattern of the Krystal Spiral and the square view can be drawn here in the seed of life with just simpler setup lines. All right, let's just break down the Krystal Spiral a little bit more and get to the roots. And what I mean by that is the square roots, and discuss a little bit more about what is going on with each of these segments as we work our way around the path that the spiral is following. Now, I know it's really hidden in the diagram, but with, you know, from the few different drawings I'm doing, I'm able to ascertain that there are additional squares, basically, that would line up along that segment in a box of three squares, let's say, three in a row, and crossing the diagonal. And that diagonal across 1 to 3, that's going to give you a value of the square root of 10. And then as I hit this point, then I'll go down and I'll be still in the same size squares. So it's basically making an L. We're going to drop down here, and we're going to pick up cross 2 squares on the diagonal. Of course, that's the square root of 5. Now, this interior angle here is 135 degrees on all the angles. You see this will just repeat at the next scale down, right? 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. And it's just, it's not doubling, you know, decreasing in size by half until you get to through 2 of these segments of 3 and 2, 3 and 2. So that's when we divide the square root of 10 by the square root of 5, as I mentioned in some of my previous videos, well, this ratio between each of the edges here, the 2 in this section here, the top of this L, those 2 are, the ratio is the square root of 2. Okay, so the ratio between each of these segments of the same size square will always be square root of 2 as it works its way around. It only doubles, as you could see, here's the 3, here's a 3, so every group of 3 squares it will double, every group of 2 squares, it's doubling there too. So it's hopscotching along as it makes its way around. Now, you don't need to draw this even in the square, as I showed you in the Seed of Life. You could do this in graph paper, let's just say, if you take a 25 square grid, and you'll have to divide some of these squares in half, but you'll see you could go 3, then 2, right? And then you have to go to the half squares of those, 3, then 2. The issue with that, of course, is we're not putting it into a sacred geometry diagram like this. We're still going to get these sacred proportions, but you don't really need the compass at all to set up this design. So you're just going to hopscotch around here on the grid and work around, but you also lose where your center is, which is nicely defined here. Okay, so there's a few issues with this spiral that I'm trying to still navigate and work my way around. I'm going to describe some of those, and hopefully some people who are relatively into this will take a look at some of these things I'm discussing with the spirals, because as you work your way around here, what I like to build this spiral on is really on these 90-degree segments, okay, the 90 degrees. So it's essentially going to do the same thing. I call this a true doubling spiral, which we're going to talk about in a little bit, because it's really just a segment length here. Is this segment is half the length of the preceding one, and then this one half the length of the preceding. So that's a real doubling sequence. There is no additional one. So if you start the spiral another 91 here on the blue, you have basically two spirals or two origin points kind of working their way around. Now, when you do put a smooth spiral onto each of these, and I hope this will make a little sense here in how I'm going to describe this. Let's say we start with our red segment back here, and we do a smooth spiral that's following along the red. You're going to see that it dips below the yellow and blue line, and then it goes above the blue dotted one, and then it drops down below, and then it dips above, and then it drops below, and it dips above. That's what it's going to do. If we start one on the next segment, we're going to start above, then we're going to go below, then we're going to go above. And what's happening here is if we do a smooth spiral on the defined path of the crystal spiral, it kind of splits that difference in half as the computer generates that spiral between one that's above and one that's below a different starting point on the spiral. I feel there's only really one 90-degree spiral within this, which I'm going to describe some reasons why in a little bit. So here is the doubling sequence rectangle, which I talked about in my previous video a little bit. And I call this the Electrum spiral, and I will tell you why. So just hold on just a moment to see why that's called the Electrum spiral. In my process of discovering this rectangle grid from about 4 or 5 years ago, before I really did any research on the crystal spiral, the outline of that does overlay. It's the same 90-degree spiral that I showed previously on the crystal spiral. Let's say it's this red one. Same 90-degree segments, but this is the actual rectangle that it fits in, which is a doubling rectangle. These two squares, large one, are going to be two smaller squares are going to be within inside that. And then so this is going to be another two small squares within that, and another two small squares there, and another two small squares there. So that is our doubling sequence. This square is going to be, this segment here is going to be half the length of that segment, and that's half the length of the preceding one. And that's essentially the same path that the crystal spiral does, and it's actually the same arc that the spiral edge here is going to touch each of these vertices as it works its way around. Now I need to just address how this Electrum spiral came to be and why I call it the Electrum spiral. Even though it matches the crystal spiral, I discovered it based on completely different fundamental concepts rather than drawing squares and just following the outline and edges of squares in that diagram. So we have what's called the metallic mean spirals, and these are based on these different integers. If the integer is 1, this is a little calculation that you could plug in. If you do the square root of 4 plus 1 squared, which is 1, that gives you the square root of 5, plus 1, that's 3.236, divided by 2, that's 1.618. The silver spiral, if you plug in the same formula, it always has the square root of 4. So we're going to say 2 squared plus the square root of 4 plus 2 divided by 2. That gives you 2.414, the bronze spiral, and you can continue on and more. Now, this is information from a book that I was working on years ago. I started writing. This is on page 157 of that book. And when I first started working with that rectangle spiral that I just showed you previously, I was like, holy smokes, I did this spiral a while ago. And in the book, I called it the Electrum spiral. This is what I said here. The author's Electrum spiral, based on a value of 1.5, which produces the metallic mean value of 2, which creates a spiral based on the doubling sequence of 2, 4, 8, 16, 32, etc. Now, that was from over about 4 years ago, was the Electrum spiral. Now, many math folks out there who are really into the metallic means are going to be like, whoa, wait a second. You introduced, a non-whole number, 1.5. So, okay, that's fine, but I'm experimenting with some other values here to see what I can do with this formula. And when I was playing around with it, I was like, oh, well, if I do this 1.5 squared plus square root of 4 plus 1.5 divided by 2, that gives me the value of 2. And 1 and 2, well, 1.5 is right between 1 and 2. So I called it the Electrum spiral because Electrum is what happens when you mix gold and silver together. And in fact, the Electrum was the coating that they would put on top, a mix of gold and silver on top of pyramids in ancient times. So that's why I went with the Electrum spiral to fit within the metallic mean, within the metallic mean kind of formula of how it has a geometric foundation and a mathematical foundation, although some mathematicians may not like the non-integer value here of being 1.5. Nevertheless, it still makes a square, which I can arc along here and make another arc and another arc through all these squares, which are going to be going down towards the defined 0 point, which would be at the center of this diagram. If I drew the cross hairs between this rectangle and that rectangle, would give me the center spot. So that's how I discovered this metallic mean. And one of the first times I drew it was actually because I wanted to discover what the polygon shape would be with this spiral. And this is where things get really kind of interesting. Now, I want to back up, just because you think I might have gone off from the Krystal spiral. The spiral you're looking at here in the Electrum spiral is the same path, the same arc, the same everything that is in these squares versus squares and squares, and just doing this little jog out here to the side. There's nothing different. The circle arc that's going around here, as I'm going to demonstrate in just a bit and show you zoomed in, is following the same path of that half arc circle that the Krystal spiral follows. Now, as you see here down the bottom, let me just mention this. Of all these metallic mean spirals, there are only 2 that have a polygon associated with them, and that is the golden spiral, which has the pentagon, of course, which has a 1 to 1.618 ratio that shows up on the cross diagonal through the star, right? Through the center of through the arm of the pentagon going across. Let's just call it the diagonal and the base. Now, the octagon holds the silver spiral, and that, if it has an edge length of 1, the length of the silver spiral there is 2.414 across that diagonal, across giving you the 2 values. So there's your ratio that shows up. So when I came up with the Electrum spiral, well, if it has a value of 2, I'm looking for a value of 1 to 2, because this has 1 to 1.618, this has 1 to 2.414, this has a value of 1 to 2. And there's only one polygon shape out there that has that, and that is a hexagon. So my first drawing of this to discover where this was 4 years ago, drawing this in PowerPoint, not even on the iPad and the way I do things in GeoGebra now. This is all just connecting little lines together. I cleaned up this image quite a bit and took out the old one, but I left the triangles. So what I did was I started out with a big hexagon, and then I put a triangle here, and that followed the curvature of that circle arc that's going around. And then I set up another hexagon there and took one triangle of that one, another hexagon, took one triangle, another hexagon, one triangle, another hexagon, one triangle. And that, what do you know, that gave me the relationship that I was looking for, the 1 to 2 in a polygon. So that's how the Electrum spiral is related to the hexagon. But the same spiral is equally related to this square setup that I'm saying over here. But fundamentally, both of them still are going to maintain these proportions. So of how the spiral goes around. Although it is going to be different. Okay, let me back up there. This is going to be a different ratio here, because where the triangle, and this is the interesting thing between these two spirals, essentially it's the same curvature that's being followed, except what is happening here is we have this square that's poking up here, defining the point that we're going to stop, that the spiral is going to follow, okay? This same circle arc. But if we pop a triangle on the base of that square, and it's blue and red here, that's going to go up and touch the same point. And then it's going to continue following around. And then I'm going to do that other triangle, right? And it's going to follow around and go past there. It's the same process. It's just this triangle and hexagon. It was really interesting for me to discover that, because in the book that I was writing 4 years ago, at that very next page, I said, now let's take a look, after that page where I said the author's Electrum spiral, blah, blah, blah. The next thing that I say is, now let's take a look at the Krystal spiral, the spiral that's out there. And I discussed that. I didn't know they were the same path was the same for them. So anyway, we're going to now put this into form, and I'm going to work with the Electrum spiral. It is the same path as the Krystal spiral in terms of the curvature of the arc going around. And so we have this rectangle here, and I'm going to use the golden rectangle as an example to learn from things I've learned about how the golden rectangle fits into form. And this fits into the Balinsky dodecahedron, meaning that the top of the dodecahedron, which is, I don't have a picture of one of those, but I do have this little zone model. So this edge length here, if you run a rectangle straight through the golden rectangle, straight through the middle, it'd be a plane looking at it this way from the side. You're going to be able to trace the outline of that spiral in the Balinsky's dodecahedron. So I said, let's go ahead and make a dodecahedron, which actually has all the same equal size faces on it, and make a Balinsky dodecahedron. Not Balinsky, that's Balinsky, I'm Leoniak. I made a Leoniak dodecahedron out of, the same concept, basically, that I was seeing over here in the Balinsky dodecahedron. So this spiral essentially is on a flat plane going through the Balinsky dodecahedron, as it is in there, and Leoniak's. And we could put these dodecahedra together, it'll fill space just like any other dodecahedron as the faces all match up. Now, the cool thing about that is that I'm able to now take that Leoniak dodecahedron and rotate it in space into the hexagon view, which means that I'm able to also adjust and shift the rectangle that is the same rectangle that the crystal spiral is now, right? And I'm able to show what the crystal spiral looks like, essentially, the Electrum spiral, because it's the same curvature in a hexagon view. So it looks like a kind of more rhombus diamond-like shape here. The yellow, orange, gold color is the shape of the spiral. And that's all I've done was just gone from our previous drawing from being flat, tilted the form to another view to see what it looks like. And I was quite surprised how easy this dodecahedron that is named after me fits into this seat of life here, and that rectangle could be drawn in there just waiting to be discovered within here, the Electrum spiral / crystal spiral, all within this dodecahedron. Now, I'm going to say this is all flat, and we're going to talk about flatland geometry for a little while. It's just that the spiral is just on one flat plane. I'm going to show in just a little bit how this spiral is going to go implosive, like I was showing in this form, and that's when things are going to get even more exciting than this already. All right, so I think we're getting close to that in just a moment. We're just going to explore a few more. Let's look at the spiral as being flat before we turn it into something that has some movement towards a center point. This is just kind of me drawing my finger in the sand kind of thing. But there's one more way to partition that long rectangle that is the two squares, okay? And basically you could partition the rectangle that would be down on this section here, right? So we have basically 1, 2, 3, 4 rectangles of this size. Once we could put it right in the center of the diagram. And in fact, it's really easy to do with just these diagonals across the two squares, which are the square root of 5 lines. Those are going to automatically divide the other rectangle just on the midpoints here, of the small squares in the corners. But when you do that, you can just go forever into the center of this drawing with that partition rectangle in the middle. Now, it doesn't look like the outline of the square, the rectangle I just showed you up here, right? Like that partitioned is down on this side. Great, we could start up here and go around. Now I've popped it right into the center of the diagram in a cool way. We just have one little issue, is that you're not going to be able to draw that arc, because what happens over here is we don't have a square anymore. So you can't actually draw this circle. Now, let me just, before I keep going on this, the most amazing thing, which I think I still have some slides for, to show how the spiral of the crystal spiral actually turns out to be this circle here that's going along, this red outline. That actually is the spiral. This is not like, that's the arc. That's the computer generated arc right here that I'm showing you, going around, computer generated, following the path of the curvature. It's not like veering off just a little bit, because it's precisely following the two doubling sequence arc of those curves, which blend into each other just perfectly as they go. I don't know how it worked out that way. All right, let me just go back over to what we was just discussing over here. So the cool thing about this is, if we don't have a square, so you can't just do your quarter arc circles easily. But I thought this was a neat representation, because what happens now is when I draw my long edges that are going to double all the way down, the blue representing the path of the spiral, that actually creates 3, 4, 5 triangles all the way. So if this edge is 3, the base of this is 4, and then the hypotenuse of those two is 5. All right, so that will happen here too, but they'll all be half the size, right? So we'll have 1.5, 2, and 2.5 for the next one, and so on and so forth, as we follow the same rectangular shape but now we just set it up into a 3, 4, 5 triangle movement to the center in this diagram. But it got me thinking about what form is this stack of 2 in, right? And that is the truncated octahedron. Now, the truncated octahedron is, we're familiar with the octahedron, which is the platonic solid with the 6 vertices and the 8 faces. So it's the octahedron that is going to be, the truncated one is going to be truncated. If we divide this edge into thirds, we take a third out of each edge, and then that produces a hexagon on each of those triangular faces. So we get hexagons and squares all the way around. And from if I'm looking at it like this, from the top down to the bottom, that's 2 squares, 1, 2, stacked on top of one another, which means I could trace out the outline of this spiral going down in towards the center, just within the truncated octahedron like that. So that got me thinking, and this is where things are going to get exciting for the next stage. But let me just go through a few more 2D type of expressions of this, because when you're gonna double now, and when you're gonna the next cube octahedron or truncated octahedron inside there is going to be half the size smaller, and then half the size smaller than the previous. So as I go black, there's one, and I hop down again, there's to the red one, to the blue one, down to the black one or purple one, maybe down in there. And as I've just followed the spiral down, so I'm seeing that there's going to be some doubling sequence that's going to go in the expression of the form. And that got me thinking about, here's just another view. Okay, so here's the hexagon view now, and here are each of those truncated octahedron nicely nested within the larger hexagon that it's kind of framed within as it goes all the way down in the center. There's 4 iterations of that as well. All right, so now we're going to get into kind of how this is going to express itself in an implosive way. This is going to change a total different way of looking at this spiral. Up until this point, we're looking at it as a flat expression like this on the right. Okay, totally flat land. It's one of my biggest questions with the crystal spiral, is asking what that is, to trying to figure out from the geometry, how is this meant to represent itself in movement through form? And it's like a mystery over there for that, for the people who are into the crystal spiral. I've really tried to dig in deep to figure it out, and I think this really changes the whole dynamic of what it means for that spiral to go to the center. I think so much of the attention of looking at this is a flatland perspective, that you trace your finger in the sand and it loops around the center point until it goes back to the center, when really we want to be looping towards something, or we don't want to. We can view it this way. It can be viewed as looping towards something, getting smaller and smaller, like a spiral that isn't just, spinning something over my head, right? And it's getting smaller, but something that's coming towards you or away from you into a spiral like that. And this is what this cone or pyramid does, that is facing in from the truncated octahedron. Now, this is the pyramid, okay? That's why that's a little smaller there, is because we're looking at it like that in the form with the edge length this. If I turn it this way, there's the circle, okay? That it would be the base. And then that cone is going into the center. Now that totally changes the orientation of what this spiral is going to look like on top of this, as it makes its way around this cone. And if you've seen my videos on the Russian pyramid, this is totally inspired by this type of way of thinking of how I studied the Russian pyramid, is that, and Charlie Zeiss has studied too, is, we stack spheres on top of one another, and then the outline of the tangent lines to all those spheres, or circles in this case here, or spheres in the actual 3D form, they're going to be tangent to that line. All right, so they're going to be all these spheres are going to be tangent to it. And each of these spheres, as we work our way down, in this case, towards the center of the form, I just flipped it over here to kind of not get so busy in here. We could basically double the smaller, sequentially smaller doubling sequence as I go in towards the center. Now that's all, how to look at this diagram is that's all happening right here, okay? In this square. It's not this huge square. That would be the next larger one of these bigger, okay? So we don't know what square we're looking at when maybe we don't know what square we're looking at when we're looking at this, right? Maybe it's already the face of a form. It's just a fragment of the form and that your spiral is right starting in here and cascading to the center on a face of a truncated octahedron, which is a square. So as we follow this down, you're going to see that I picked up these lines. I'm going to zoom in on this just so you could track your way down into the center. And I have a form right here, which I'll show some pictures on. It'll be easier to see to show what that spiral looks like, just like what I did with the Russian pyramid. Now, just like Charlie Zeiss has made 76.345, the anthem song for the phi ratio pyramid, writing a whole 500-page tome called 76.345. Well, 70.528 is equally as important in the doubling sequence pyramid, which this is, okay? The Electrum pyramid, I like to call it now. And it's a 70.528. That's the number. And if that is the tetrahedron angle of the bottom of a tetrahedron, if you hold it from the side like this, that angle is showing up there. This angle is showing up in octahedron too. And it's closely associated with the tetrahedron bonding angle of 109.47. It's the opposite of it, okay? So this has got a deep relationship to this Platonic solid geometry, is 75-8, and it's a doubling sequence pyramid. The ratios here are so simple. It's mind-bogglingly simple to create this drawing. Just 1, 1.5, and square root of 2. This will go straight into the center of the diagram from those 6 faces. Here's going to be just a zoomed up version of what we were just looking at here. Okay, this is the doubling sequence spiral to the center. It's electrifying. Well, there you go. It's a close-up view of how that same view of the Electrum spiral, remember, you can easily turn this into the Krystal Spiral. I've already demonstrated it's following the same curvature. So, and then this is going to be what this arc looks like on the side of the form, and I'll show you what it looks like from top down in a slide coming up. So here is the standard Krystal Spiral view with the spiral there. Let's just go ahead and take that. I didn't draw this one. This is just from an image online, just so I am using another source to kind of overlay on top. You'll see that there's no issue with how that's going to overlay on the same path of the spiral. And this puts it all into motion in a true doubling sequence spiral. And it's going to be tricky to find those other points. That's why I'm basically just going on 90-degree arcs, because you just go 90, 90, 90 to the next location on the sphere. There's no 135 mixed in there. Now, the spiral is going to have a lot of points along there, but to just do this quick method, it's quite easy to just do the 90-degree turns like that. Just another view of it from a different view of the truncated octahedron. Here is this black pyramid, the Electrum pyramid at the top. This is the outline of the spiral, the dotted purple line. This is where it is way in here. And what I'm trying to illustrate in here, which may be a little more complicated in this drawing to decipher, but these gold pyramids here are the same angle. Now, this is a big octahedron. It's blue. Okay, the truncated octahedron is outlined in black. All right, there's the thirds along here. 1, 2, 3. There's 3 parts. But if you divide an octahedron edge, okay, into midpoint, right, then you get your cube octahedron. All right, here's your cube octahedron, super familiar form, maybe probably the most popular Archimedean solid out there. There's your cube octahedron as a hexagon. That would be the hexagon that it's going to create within this form. As it truncate everything away, this is what you're left with. Now, if I build the same Electrum pyramid, which is this guy right here, and I put it on that square face at the bottom, right? I'm going to put an Electrum pyramid right here at the bottom of this, and I'm going to send it straight up. You know where that lands on there? Well, it ends at the other side. It ends up here at the top. So Electrum pyramid at the bottom, going to come up to the top and meet at the center point of the square on the opposite side of the form. So that is not going to get the Electrum pyramid to transfer the spiral doubling sequence into the center. It hops all the way over. If I bring my pyramid back here, right, one step back and then send it up, there it goes right to the center. And that is the truncated octahedron, okay? That's the square face. It doesn't, is this one, all right, on the truncated octahedron, dividing the octahedron into thirds, not in the midpoint on the cube octahedron. Doesn't mean that the cube octahedron is super not important to the whole structure. Totally not. It's going to be the 0 point in the center of all these forms, which I will demonstrate as well. But it's it doesn't send from the square face up to the center like it did. Now, we probably could draw a smaller square in there and work our way down, no doubt. And I'll have to check that out because that's a new thought that popped in my head. But we could probably get that from a smaller face on the same face if we want it. All right, so here's the kind of ultimate expression of the form, and that was me and Nancy built. And just as an aside, Nancy and I are going to run a drawing class coming up here at the end of January here. Check that out. We're doing a drawing through the seasons, a $9 drawing class. It's going to be a lot of fun. We're going to have a seasonal drawing 4 times a year. So check that out at New Geometrics course site. But her and I built, that's why there's 2 different color ones. We actually built, I built one of them to test it out first, and then we built one together. But here the 2 of these are, and from 3 different views that I'm showing you, here is the square base with the cones going into the middle. Here's what this cone looks like. We're going to spend a little time talking about this hexagon cone for just a little bit. Nice, cool star pattern that makes. And here it is from another view. So we built all the cones, and all this cone matches to fit in next to all the other cones, and they all meet at the center. So this is a cool little doubling sequence implosion ball created from the sacred geometry that you're seeing here. And these are the same spirals. This is the spiral paths. I did 8 of them, all going down into the center point of the form. And this is kind of a view of the hexagon cap and the spiral that's following. And they're going to meet actually at the same points as it goes around 6 times. It's going to meet at the doubling sequence location on the 4 side. They'll meet at the same plane to reproduce the next form, next octahedron lower into the form. They're going to meet on that form, and then they're going to meet on the next smaller one in there. So it's all linked up structurally like that, and the spirals are moving through the structure of the forms and creating the vertices of them, and creating the forms as well, and as well as just following the expression that the geometry guides the movement of that Electrum spiral. All right, so this was a cool exploration. I figured out all the hand-drawn techniques to be able to do this. This is going to turn into a course that I'm going to do on this, much like I did on the golden ratio pyramids, which is the Giza pyramid and the Russian pyramid. How to draw those in 2D hand-drawn drawing techniques, and transfer those over to actually build the cone. Go ahead and build the pyramid, make the spiral on it, show the expression of it, how the little square of the nest that fits in here, and then what it looks like. Here is the spiral on that cone, right? That's the spiral on the cone. There's the curvature right there on the paper. this fits right inside because the circumference of this circle fits within that square. Doing new sacred geometry is where it all clicks. You got to move out of the if you're not drawing yet and you're in the armchair sacred geometry state, like many of us have been for a long time, and like I was, seeing this all around us all the time and being, wow, that's so cool, and that's it. But when you get your hands engaged with it, that's where it all clicks. That's where the real transmission of the information that really comes through and lives inside you is when you build this and contemplate, meditate on it, get engaged with the language. You know, it's a living language to get engaged within, and that's what these types of courses over New Geometries courses are designed to do, to expand consciousness and have a great time doing it, because this is just really cool stuff. One little aside here that I wanna add is this is just totally amazing to me that this worked out this way, right? When I made the Russian pyramid cones for that course and for my own studies in this, those cones were tough to figure out the correct angle, because you're going to fold up a cone and you want it to have the circumference of the circle that you want to fit in the base of the pyramid. Turns out I figured out some more simple calculations, but I scratched my head on it for a little while, scratched my head about it for a while. And this just shows how integrated this sacred geometry is. This is a doubling sequence pyramid. This is the 1, 2, 4, 8, 16, 32, 64. This is a doubling sequence pyramid. This is a doubling sequence cone. So if you're anti-hexagon after this, if you think hexagons have nothing to offer to geometry or sacred geometry, like I've heard so many times in any videos I've done, posts I make, etc., what do you think the angle is to fold up and make that cone? You could do it tonight with 3 circles. It's a 120-degree angle. That's a part of a hexagon, right? That's 2 triangles, right? 60-degree triangles, equilateral. That's your cone, 120-degree angle. You cut out this little 120-degree angle, fold it up, and you have made a doubling sequence cone just like that. And it's based on a hexagon, the doubling sequence cone. So there is an integrated relationship. I would not, if you're into the Krystal Spiral and you're involved in all the rhetoric that's engaged with that of the Daisy of Death or Metatronic this and that, then I think that you're really throwing out something in terms of how integrated geometry is at levels that far supersede our beliefs about it. And this just clearly showed me that if you want to create the doubling sequence with this spiral on top for a cone that implodes into the middle at a doubling sequence, you have to fold up a 120-degree cone to make that happen. Okay, so let's take a look here at this next little bit of, it's just a little side excursion here, because I love thinking, well, if everything's going in, right? All these, like in the form back here, everything is going in. We got this cone going in, that cone going in. Well, let's just flip those cones around to the outside and point them out. What are we going to get, right? Well, that's pretty nice. We get the rhombic dodecahedron, which is this form right here, a little easier to see than the line drawing of it. But the outline here in the gold is basically the vertices are given by those 6 pyramids, which are going in and out at the same time here, in addition to the hexagon caps that I was just showing you as well. Those are going to flip around. Those are going to, 8 of those. Well, great. Cube has 8 vertices. We get that. We have 6 vertices for the cube. Well, let's just connect all the dots. We've imploded to the outside here, and we get another fundamental building block of structure of creation, the rhombic dodecahedron, which will fill space infinitely in the most tightest spherical packing way you can do it. So that's the rhombic dodecahedron, and all it was just flipping those cones and pyramids, the hexagon pyramid and the square pyramid around to go ahead and recreate this. And I'll show you at the end what do you think happens when you just start plugging all these things together? The inside meets the outside, and the outside meets the inside of another one. Well, then you're into the full construct of how all these forms are interrelated, and how I think maybe Nassim Haramein says it's a smoothie universe, how you get these little vortices going from the center of one, the vortice of going to the center of another, in all these different directions. Well, then you're getting a little closer to a model that actually isn't just about static points, but the transfer of energy through spirals moving from one center point to another center point through these toroidal shapes, I can imagine, all being clustered around the locations at the tops of the center tops of these little smoke donuts going on and on. All right, so let's just get into a little comparison on the Electrum pyramid, the 70.528, to the Russian pyramid of the 76.345. So we've got both of the pyramids laid out. Here's the angle of the base angle, 76. Here's the base angle of the 70. This is if the edge is facing you. This is the edge facing you. This is the face. This is the face angle, is where the slant angle is taken from. This is the top-down view. These two are scaled to be the same size, and at the top. And here is an example of the drawing of this one. And I had to come up with a new octahedron, the Russian truncated octahedron, which is this guy over here, and this one over here on the right. But you could see I wanted to discover how to make what I just did with the truncation of the regular octahedron. I wanted to put cones in, and I wanted to do it with Russian pyramids. So I did make a Russian pyramid version of this truncated octahedron with irregular hexagon faces. I have all the proportions of that written down somewhere else. I did build that, and some cool things that I discovered when doing this that I just talked about in a video I did with Charlie Zeiss, but some of my viewers probably have not seen that, and I wanted to drop it into this video here, is that so that hexagon pyramid that's within this form, right? So everything's so much about the square pyramid. And I was curious, well, what's going to go on with this hexagon, irregular hexagon pyramid over here, right? So now the Russian pyramid, if you're not familiar with it, the thing that it does is it stacks just like I showed you with the doubling sequence pyramid, which is stacking if this circle here would be 8, right? Then this would be 4, then that would be 2, then that would be 1, etc. Right? So that's gonna decrease in that rate. But the Russian pyramid has stacked spheres. If this is 2.618, then we're going to 1.618, then we're going to 1, then we're going to 0.618. So those are going to descend down in that way. Now, the Giza pyramid, basically the relationship on the straight up Giza pyramid, 76.345 at the top, which happens to be the corner angle down here. And notice, I have two spheres here. Well, those are in a 1 to phi cubed relationship. So this big circle you hear, if I jump all the way, I'm skipping two circles until I get to this one. Well, that's phi cubed. And then the next smallest one will be phi cubed on top of that, a little circle on top. So that's what the Giza pyramid does. If you nest it on the face with the 51.8273 angle on the side there, you're going to jump and you're going to go to the next 1 to phi cubed, okay, which is 4.236. Okay, that's the value for phi cubed, 1 to phi cubed. So we have 76.345 at the top, right? That's that base angle. And then this was really interesting because here's this hexagon. I tilted it. Pretend this is the base and you're looking at it flat. Here are these edges, this edge coming back, right? This is that back edge. This is the front. All right, so we're looking at that. Oh, here, I have one here so you can visualize it like this. So I've got this, and I'm just holding it like this. There's the bottom. I flipped it down. So, okay, I stacked my circles in there, but they're tilted. They're not going straight up like the Giza pyramid. They're going off and leaning to the left. It's like someone sat down on the Giza pyramid that you just made and crushed and tilted a little bit to the left, but at least the 76.345 angle stayed intact. Because if it does, what happens is that those spheres that are in there, they're going to maintain the same relationship that if the Giza pyramid was flat. And what this showed me was, you know what? It's not so important what the base angle is, 51.8273. That only is going to show you if you want it to be a perfectly square base like that. But if your pyramid tilts like this, as long as you maintain the top angle, 76.345, even on this, which has an angle of 65.5 and 38.2, this is really tilted. Well, as long as that's 76.345, you're still going to be able to put the two spheres in there that are 1 to 5 cubed. All right, I'm going too far into this one, but that was just a really interesting part of this new pyramid. But I do want to set it up to make some comparisons. That's why we kind of went into that. I had to basically construct a new form, but I didn't have to do that yet. I could have just compared these like this. So let's take a look at this. Okay, well, we're going to compare the two pyramids, and they're at the same height. Here would be the midpoint, basically, on where this spiral hits here. Well, that would be the midpoint of the same Russian spiral, the midpoint. They both share the same midpoint on both. And I've blown them up so we could really compare the two spirals and their paths up the spiral of energy towards the center point of the infinity spot at the center of the diagram, the 0 point at the center. Now, we're going to zoom into this a little bit later, but these are what the two spirals look like if we're looking at them from top down. And if I go ahead and look at them from the side, you got the blue one. That is the Electrum spiral or Krystal spiral. Here we go. Here's the other one, the golden spiral going up. Now, when we look at this little section right here, let's just take a look at the next slide. On a 2D diagram like this, this is going to look like these two spirals intersect. They cross each other. And the reason I'm bringing this up is because recently, of a month ago and from a couple of years ago, there were some videos talking about the time wave spiral separation. I even did 2 videos on it recently discussing some of this. And remember, that's like we're looking at these diagrams from a flatland perspective, 2D. This turns us into a 3-dimensional, ascendance of energy or spiral going up, ascendance moving up this or down, or whatever way you want to look at it. We're getting a spiral moving up a cone. It's following the ratio of that particular doubling sequence or golden ratio. So the red one's the doubling, the purple one there is the Russian. And on this, they look like they're crossing each other, but in the reality of what's happening on the respected pyramid structures or cone structures, there's this much space between them. I mean, this is a whole height away, an inch away, let's call it, an inch away from the spiral that's below it. So it only really appears to us in flatland like those two spirals have crossed each other, but the other one's well above it by that point. So there's really no crossing or interaction that has gone on between those two spirals. It just appears that way when we look at 2D diagrams. So I don't know what that means, just something to contemplate as a time wave separator if you're into thinking about that recent event that has happened like a month ago, according to the Krystal Spiral Research Foundation, whatever that is. Let's go ahead and take a look at one little issue I was wanted to resolve with the Russian pyramid in the triacontahedron. Now, the rhombic triacontahedron is this 30 diamond shaped form. And if you check out my Russian pyramid videos, I talk a lot about this. And there was always an issue that it had was that the cone fit perfectly with inside the opening at the top of the form. The cone didn't have an issue on the rhombic face, but the base of the pyramid did. It extended by. And what I mean by this is I tried to just take 30 Russian pyramids and put them together in this first form And right away, I noticed that it was going to be too big at the base by just a little bit, so that it pushed everything out and they would not all meet at the center. So I had to take this truncated octahedron that I just showed you, the Russian pyramid version of that. And what I had to do was rotate that around so that that pyramid is going to pop through each of these faces, and that's going to reconstruct the 30 faces. So there's going to be 30 squares. That will reconstruct, following icosahedral symmetry, what a form would look like if it had 30 Russian pyramids going into the center. And of course, I had to build the golden implosion ball, and because it had been a long mystery for me. And essentially what it had to do was, it's following the icosahedral symmetry. We have 30 of these around, so it's like a rhombic tricontahedron. We're just trimming off a little bit of the point of the tricontahedron, of the dodecahedron, icosahedron crossing. There's some great golden values that show up in all this. It was quite a great learning experience to see how all this golden geometry is related. Just didn't come up with random numbers that did this. It was all specific. But when we trim that away just like this, then we're able to nest all these properly inside the form, which is just an incredible little form too, of the 30 Russian pyramids going all around in the structure. And there are the three views of that: square, hexagon, and pentagon views of it. Now you might want to ask, is like, well, can you do that with the regular truncated octahedron too? And of course, I had to do that too, and I have a few different drawings of it. The issue is when we go to building it with form, you're going to see that the square faces that we're working with, they crisscross each other. Okay, so there's blue. It's on the opposite side, which means that opposite one is another square, and there's another square that crosses here. So all of a sudden, we get this crisscrossing at the corners. Now, as I'm thinking and saying that, that doesn't mean that the cone itself might not nest in there, right? Because if we're trimming off the corner, well, that's not really a big issue, because we're going to lose the corner anyway if we're dealing with a cone, right? So this may still fit all the cones in those areas, but this is unknown at this point because I didn't explore that. But we can't just put all the pyramids together. So I'm going to take a look at that and explore that just a little bit more. But this is a beautiful expression of this form that I could draw in pentagon view that is kind of exhibiting both dodecahedron and icosahedron looks of those compound 6 versions that I did in my master classes and the cosmic geometry videos, if you want to check those out. Okay, so we're getting close to the end, and this is now really going to take a dimensional shift in how were we even viewing these objects, particularly in square view, we're going to look at here. So this is just a little bit of a warm-up. I wish I removed all the circles here, but the outline of these octagons, if you can make those out, there's 2 octagons here. There's a hexagon face, there's a hexagon face. Those are the truncated octahedron. And what's going to happen with those 2 truncated octahedron is they're gonna like butt up against each other, hexagon to hexagon face. I know I got a golden hexagon version here, but hexagon to hexagon face like that. And as you put them up to each other, hexagon to hexagon face, well, they're sharing the same hexagon. And as we do that, we have a hexagon sharing. Well, that's this right here, this little star, this little shape right there. That's where 2 hexagons are meeting. That's a blue and a red. Picture a Star of David shape to hexagram tilted. Now, this right here is a tilted hexagon, and this is, in the structure of this form, the star-cut diagram can actually be the star-cut diagram itself can turn into the outline of these crisscrossing hexagons. So I'm not going to explore that too much, but here's another example of that, how I'm laying out all the internal geometry within this form. I've placed a large hexagon over this, but there's actually a form in this that I want to discuss for just a little bit. And you could see that that is the outline. This is like the inner core, just coming from one direction, where those two hexagons met. See that outline of that shape that I'm showing you there? Okay, that is in the core of these two forms, the two truncated octahedron coming together. And there is where that little hexagon meeting spot is, right in the middle there, right? Now, the reason I'm going on and on about this and why it's super interesting is this big shape here that I have on my right. Well, that's the 12 tricathar grid hexagon. You know, it's the same shape as the hexagon. Here's the cathar grid. Here's your crystal spiral. Oh, wow, it fits right over that. And, whoops, taking the wrong one. I got to drop that one to the back. Let's do that. Let's see. Send to back. It doesn't want to do it. Oop. Let's see. I gotta restart it. Crashed on me. Let me just shut down the PowerPoint. But I'll show off some other forms and then we'll get back to that. So that little form that I'm showing you there is essentially this. I kind of try to make like a 3D wire model of that. And hold on a sec, I just got to get the recording back. I mean, not the recording, the video presentation. This is the same outline of what I was just showing you, as best as I could make it. And it has basically that same little cap up at the top and the same cap going down in the middle, and they're meeting at the middle. Here's the hexagon outline where they're crossing one another. And this is essentially what that form is, with those two coming together. And this is the meeting point, and each of these hexagon bits are part of this form right here. All right. So that's the same hexagon at the top of there and the hexagon on the bottom. So this essentially is in the core of this structure going this way, but it's not only going one way like that. If I hold it straight up and down, it would kind of be like that, right? It would also be going that way and towards me. So it's like a little inner core. The vertices on the outside are going to go ahead and create like a cube. But let me go ahead and go back to the screen share on that